Hello there. My name is Hamilton, and while I used to teach code, I don't teach it as much anymore, but about a year ago, 2 years ago, somewhere in there, I made a video about how to make a game engine from scratch in JavaScript. And today, I'm going to add on to it because a number of people asked me about it, and they were like, "Hey, can you when you making part two?" And I just kind of never got around to it. So today we're going to try to get around to it. Last time we left off, we had the most rudimentary of game engines, which was essentially just a drawing engine that could draw over time to a canvas. How does that work? Well, we made an HTML file that has a canvas on it. We loaded in a module JavaScript file, and then we made a source folder with a number of JavaScript files, and that included things like our main file from which our loop was begun. We recorded our delta time, and then we began the loop of our game by running our level. Inside of our level is where all the code of our quote-unquote game lies. The main is what starts the engine, and the level is what is your game. At that point, then we made a number of things like a settings file. We made a pointer file that showed us the positions of our mouse at any one time, and we made a canvas file that allowed us to use the canvas tools available to us in a more easy to use fashion. Now, a couple of things have happened in the time since I made this. One, AI has made the leap into especially the coding world, and I have Copilot on in VS Code, and if you've never used AI or Copilot before, just know that it is essentially like IntelliSense, the thing where you start typing something and it tells you what you probably meant to type. It's just that on steroids, if you want it to be, and then it can be more if you want it to be. That's how I'll be using it. Or at least that's how you'll probably see me using it. I will probably ignore it most of the time, but if you see something popping up on the screen that I haven't written yet and I don't use it, that's probably what that is. And if I do use it, that's what that is too. So there's that. Two, there's a couple of things that we want to make today to improve our game engine or make it more usable as an engine. We're probably not going to have a game at all but at the end of this, but we will have more of our engine. And that was kind of the point of the original thing, was that we didn't have a game at the end. We had an engine that ran code and a place to run our code. And that was the engine. So today we're going to do a couple of more things. Thing number one, we're going to make a debugger, because as we move forward, we're going to have more and more numbers that we sort of need to be able to see what they are at any one time and whether they're right and whether they're wrong. And I have often found that the inspector's debugging tools are not up to what I need them to be when it comes to debugging a game or debugging the kind of code that we're running. And so we're going to make our own debugger. And we're just going to kind of do that almost automatically. We're going to do one other thing. We're going to move some of our code into a couple of different places. We're going to make a new folder inside of our source, and we're going to call it engine. We're going to move most of our stuff, yeah, sure, up into our engine. We're going to move our main up into our engine. Yeah, sure, imports. Our pointer is going to go up into our engine. We're going to move our settings up into our engine. And then we're going to make a new folder inside of our source, and we're going to call it levels. And then we're going to move our level into levels. And that should have just updated all of our files that needed to import anything. No, it did not update this. So let's make sure that that now says source engine. We now have the canvas doesn't import anything. This now imports level from .levels. That looks right. Pointer and settings are from here. Pointer doesn't import anything. Settings doesn't import anything. Levels imported from engine. Cool. Okay, so our imports all look like they have updated. Excellent. Fantastic. Now we're going to make a new file inside of our engine, and we are going to call it debug.js. Now, debug.js is going to include a couple of classes and also some functions that are essentially going to give us the look. We're going to recreate a little bit of what the console does, but you'll probably learn something in the process. So, fuck it, let's do it. Let's make a new class, and let's call it Debugger. You can call this something more. I use these so often that I kind of like to just make them small. That's why I name things the way I do. In the last comments for the last video, someone asked me why I wasn't making this in TypeScript, and it's because I find TypeScript to be great for long-lived projects and terrible for short startup projects, and I don't like to deal with it, even though I use it every day at work. And you'll find that I was also, comments were brought up about my naming, and I have no thoughts that my names are perfect or right or good. However, you know, if you see something and you want to name it something else, you do that. The only difference is that you have to remember what you named it when you use it again. If you use the exact same name I used, then you'll be in the exact same spot I am. And if you name it something else, something better, you'll just have to remember every time you used it that you named it something different. So let's make a debugger class. You'll notice that as soon as I do that, Copilot starts giving me options, thoughts about what I should do. I'm going to make a static static. I'm going to call this items. I'm going to call it underscore for reasons, but we're going to make an items thing here. And we're going to make a couple of getters and functions. I'm going to make a static function called get. And this is going to return something from this.items. It's going to return something from our this.items, yes, but we're going to find inside of here anything that has the name that we just brought up. Now, you'll notice that I just hit tab because Copilot has suggested something that I finally liked. It was suggesting things the entire time, and I didn't like any of them. They might have been fine, but they weren't actually what I needed. This is what I wanted, and as soon as it figured out enough to give me what I wanted, I'm cool with tabbing over and accepting what Copilot does. And if you have used Copilot before, you will find that that is a great way to use Copilot. Is if you like it immediately, use it. It's probably right with a small enough bit of code like this, especially something where you already have a name and it already has a concept, like it knows debugger means debugger. It's got a good idea. And so it might be fine. It also learns from the other code that you have. This is not a thing about Copilot. Just you don't have to use it, but you should never turn it off, because every once in a while it will pop something up and you'll be like, oh, I like what it's telling me to do, and you should do it. So let's make a static type, and type is going to accept something that returns nearly the exact same thing, except whereas get finds one item, type will find a list of items. So find is an array function that returns one item, and filter is an array function that returns many items potentially, or one item but always an array. At that point, we're going to do a static. You know what? I like exactly where Copilot's head is at. That's exactly what I wanted. Exactly as I wanted it. Perfect. Thank you, Copilot. Now, I need a remove. Does this look like what I want for my remove? This looks perfect. Thank you, Copilot. Copilot knew exactly what I wanted, and it gave it to me because it was a simple enough task for it to do, and it could see where I was going as it. Anyway, again, we're not talking about Copilot, but it's pretty neat. If you haven't used it before, it's pretty neat. Let's do a static draw, because this debugger is going to draw to our screen, not to our console. It's going to draw to our screen so that anytime we're using this, we can just see our debugger. And inside of here, we are going to const a div. It is going to be... You know what? I don't want it to make a new div. That's not what I want it to do. Instead, let's go into our index.html, and let's make something in here. Let's make a debugger right here. And then inside of that, let's make a list, and let's make a quick. And you'll see what I want from those later, but let's just make one of the things that people forget when they start making these JavaScript engines is that you're still working in HTML. So if you want to, you can make levels and layers in HTML. You can add 15 canvases on here and access each of them individually as different layers in your game. You're not limited by this canvas like some engines would limit you. You are unlimited in this engine at the moment, except by your own creativity and knowledge. But let's make a new layer in our actual page that can be placed in front of our canvas. So we make it after the canvas, so it's easier to place it in front. And then we'll design it from there. Let's just go ahead inside of our source. Let's make a new file called style.css. And let's pull our canvas code into there. And then in our HTML, let's go ahead and link our CSS. And again, Copilot is I gotta be honest with you. Anyone who has Copilot available to them and doesn't use it, is just missing out on so much saved time for little things like that. Okay, let's go to our style.css. Inside of here, let's say that our debugger is, oh my gosh, it keeps typing things I don't want it to, is going to be a position absolute. There are reasons we did the other one at fixed, but for right now, we'll do this as absolute. We'll do it at top 10 pixels, left 10 pixels. We'll do this as background color. We kind of want to be able to see through this, so we're going to do this as FFFFF, and then we're going to put this at like 5.5 alpha. Now, you might not ever want to write 8-character hex codes, but essentially these last 2 digits here are alpha instead of RGB. That's I don't know. Sometimes I do that. Don't worry about it. And then we'll do a padding on this of 10 pixels. We'll do a font size on this of 8 pixels. We actually want this very, very small because some of the data we might want to put in there can become kind of large. And so it's nice. You might also see me like reorganizing some things that I did before. Don't worry about it. We got our debugger on here. So now if I inspect, it's way down here. Why is it way down there? We didn't get the CSS. Why didn't we get the CSS? Did I not call that debugger? Class, debugger, style, style, source, styles. It's not in styles. It's not called main.css. Oh, I was so proud of Copilot earlier, and then this is why you always have to check it, you guys. Sometimes it's right, sometimes it's not. Sometimes it has ideas. It's not really good about knowing file names. It is really good about knowing code in files. That's an annoying thing about it. Sometimes it's okay about knowing file names. It's not always perfect. Do we have our debugger now? There's our debugger right there. Perfect. Excellent. Let's make our debugger also have a pointer events of none so that we can never interact with it, so that we can always play our game and it never gets in our way no matter how big it is. Even if it's covering everything, we can still play our game. It will completely ignore our pointer events. Excellent. We're done with style.css. Cool. Okay, let's change this to be document.query selector. Now notice again, Copilot is trying to help, but it didn't quite find what we had in the other file. However, the more things we make in our code, the better Copilot is about recognizing the things that we might want in the future. Let's call this the debugger list, is what we actually want to select here. Let's say that the divs inner HTML equals this dot items. Well, let's look at what it just gave us. It has given us something where we have reduced our item to a div that has a class, and then it joins them all together so that we are mapping it onto a bunch of divs that then join together, and that's now our HTML. And because it's being joined as a one long string instead of an array. All right, cool. I have no problems with that. Thank you, Copilot. If this dot quick, remember I made that other thing that was called quick, then what we're going to want to do is say that div equals debugger.quick. Notice that this time Copilot was better. I'm going to keep saying stuff like that, because once you get Copilot in your project, you have to pay attention to it. Otherwise, things might get bad. And we're going to say that div.inner HTML equals, let's just say one thing like this, this.quick dot all of those things. Let's do that for right now. In order to do this actually right, what we've got here is this debugger got static. methods, as we did in the previous code. It's got this array right here, which this could probably be a hashtag. I'm not exactly sure why I made. You know what? I'm going to go ahead and make this a hashtag. There we go. Let's make it a private. Static means that you can only access it from the object itself, not from any instances. And the hashtag means that it's private, which means that only the debugger itself can access its items. No one else is actually allowed to access this items thing. Only the debugger class itself can access that. You can't say debugger.items. It won't exist outside. We're going to go ahead and make another class, and this class is going to be called oneBug. OneBug is going to have a constructor. This will be individual items. They will have a name and a checker function. The checker function will essentially be a function that will run anytime this bug is called. It will be able to do something, but for right now, we're going to give it a name, a checker, and then we're going to add this to the debugger. So we're going to do this. Anytime a bug is created, anytime a bug instance is made, it will add itself to the debugger. Anytime it adds itself to the debugger, it will push the item that just got passed into it into the debugger. That means the debugger will now be filled with bugs. And what that means is we can then say that this has a value string dot bind to this. And then we've got an object string that is going to bind to this as well. And then we are going to make a getter function called toString. And it is going to return a function we're going to make in a second called a bug string. That's basically going to take this bug and turn it into a string that can be printed. It'll take this dot name and this dot checker. We have our individual bugs now, and we have our debugger, basically array, that can be pushed to and that can draw all of its bugs out. And then what we've got here is we're going to make this new function called bugstring. So we're going to make a const called bugstring. It takes a name, a checker, a type that we're going to say that by default is bug. And then inside of here, we're going to return a value. And that value is basically going to be this thing right here. It's basically going to be this, because Copilot was pretty smart there. But we're going to modify a couple of things. One, this class is actually just going to be a variation on type. So whatever the type is, that's going to be the class right here. We're going to say that the name is going to be strong, so it will be bold by default. If the type of the checker equals, this should be the current value, and this should be a call to the checker. The way we're going to make this is that anytime you make a bug, you can ask it to check a value. If you pass a value in, it will be passed by value, but if you pass it in with a function, it will be checked every single time that this function is called. So it will check the value live every single time that the bug is attempted to be drawn. So that's why we're actually making checker here is a function, but it's going to then send the bug string essentially a key and a value pair. So that's what we've got here. We've got a name and a value. So this should have been a value right here. So not checker, but value. We're going to say if type of value equals an object, then we want to make an object string. Otherwise, we want to make a value string. And the reason it knows that is because we've got these two little functions right here. Now, we actually haven't made those into functions. And in fact, right here, these two functions are going to be named with camel case, whereas these two values on the bug are actually a simple rebinding of these two functions, which we are also now going to make. I'm also missing a brace. Okay, so now we're going to make two new functions. We've got a const object string. We've got a const value string. This and this. We need to essentially make something that looks like the output of the console when you like log out of console. When you say, you know, show me window, and it prints out this data, and it's in a sort of a readable format with like coloring and highlighting and like tabbing and all that kind of stuff. We want to be able to do a very similar thing. So we're going to try to do a very similar thing. We're going to make it as simple as possible. We're going to make, oh, by the way, one of the things is that the last time I wrote this, I was in the habit of writing a bunch of code that used lets, because I figured that the default way you should use something is that let is the default way you write every property or every variable, and that const is only used when you know something isn't going to change. But honestly, it should be the opposite way. Variables that you make should come out as const and be const and be assumed that they are constant. And then if you know that a variable is going to change over time, that's when you can make it a let. Now, I don't think that either one of these ways is actually correctly right, but if you have a small function like this and you make a variable and that variable never changes value, it should be a const. It never changed, and therefore it doesn't change, and therefore it shouldn't be expected to change. And actually, if it changes, that would be like, whoa, something happened. That's weird. So my mind has changed on this. Who knows? Maybe my mind will change again. That's where I'm at. I'm going to be using const more often than let, and let will be a rare instance of a variable that changes within its scope. So we're going to const out a set of values, and they are going to be an operator left, an operator right, and operator separator. There we go. So we got an operator right, operator left, and an operator separator. And we're actually going to say that by default, the operator separator equals a comma, and that way we can ignore it over here. What we're going to say here is that if array.is array of value, question mark, these two symbols here be brackets, L and R brackets. But if it's not an array, that means it's probably an object, and that means we can use braces. The idea here is that if we have any simple value, we're going to show that simple value as if it was right here, as if it was blue or red, right? String or a number. But if it's more complex, if it's an array, it'll show it with brackets. If it's an object, it'll show it with braces. That's the idea. Okay, so we've got our operator left, our operator right, and our operator separator. At that point, we are going to return a string, and that string is going to, well, let's look at what it gave us here. We've got our operator left, but in order to show that operator left, we are going to put a span around it, and that span is going to have a class. We're going to call this bug operator, or bug O, and then we are going to put our span closer around that. Down here, we are going to have another bug operator, which is going to be down here. And then inside of here, we have our object.entries. We're going to map those to key value. Inside of here, when we show our value, what we're going to do is show a bug string. And that bug string is going to be passed key rv, and it is going to be called a bug prop. Now, down here, we said that the default type of bug string was bug, but now we're going to say that this is a bug property. So this is one bug property. This is supposed to be name, not i.name. There we go. I missed that. I bet someone was screaming at my screen the whole time. we're going to make something here that is going to be a little bit more complex. Oh, look, yeah, see, it's got an idea of what we want to do. Let's just copy it for fun, and let's see what it's got here. If it is an object, then return an object string. That seems a bit superfluous, but let's try it anyways. We're going to say that over here we've got a string and a number and an other kind of value that we really care about. I don't think we're ever going to see a function, and I don't think we care about it. I don't think we care about undefined right now, and I kind of don't think we care about Boolean either. I think what we care about is merely string and number. And the way we're going to do this is we're going to say that if the type of value is a string, then it is a bug S, but we're also going to say that all of these are bug V as well. So they're all a bug value, but they could be some other thing. So we can design them all similarly as bug V, but then differently as each of their separate things. Yeah, I think that's all we care about. Let's also say that if this thing is a number, then what we want is to math.round value plus number dot epsilon times 100 divided by 100. We don't want to see any huge big numbers, and this is going to give us a way of making sure that none of our numbers are too small, but they are close enough. That's basically what that is. I think that's good. That was a lot of code that we just wrote. How long have I been recording now? Does it tell me? Will this thing tell me how long I've been recording? It doesn't. No, it does. I've been recording for 30 minutes for this one section. Oh, this video is going to be long. Okay. We've got a debugger. We've got a bug. I actually want to rewrite something in here because I realized that I did it wrong. This right here should almost certainly be a bug string. Yeah. Whoops. I wrote that wrong. We're going to call that quick, and it's going to be this dot quick. Up here, so remember when we made this toString of our bug? We can use that in a lot of different places, but the easiest place we can use it is actually right here. We can just say that we want to return our i.toString. And yeah, there we go. We can just return the i.toString, and then it will do the bug string for that. Do we need a quick? I think we need a quick. Static quick equals null. Let's do that. Oh my gosh, you guys. That was our debugger. Did anything break? Okay, no. Our code is still running. That's good. But we have a full debugger. How the heck do we use this debugger? Let's find out. Let's set up a couple of bugs. I'll set up a bug. I'll say a new bug is going to be called pointer, and it's going to return a function that returns pointer.position. I need to make sure that anytime the main runs, we also call debugger.run. Is that right? Let me see. Debugger.draw. Do we have console errors? Okay. I made some mistakes, or at least I need to change some things. Let's move this debugger.draw over to our level. Let's put it in the middle of our run. Now, at that point, bug is not defined over here. When I pulled this in, it didn't pull in bug. So let's pull in bug. Hey, look at that. Now we got a bug being pulled in. Now it says debugger isn't defined. Let's pull in debugger. Yeah. Let's pull in debugger up here. Let's delete it from there. Let's save. Let's refresh. Okay. Let's just do some actual code debugging. Let's make sure we return this value. And let's console.log our I. Is it showing us anything? Bug. Pointer. Why does it not have a toString function? Did I spell it wrong? Oh my goodness, you guys. It's just a property. Hey, look at that. All right, cool. Stop console logging. Stop it. Stop it. Okay. Let's save that again. Hey, look! Oh my goodness, you guys, look at this! We've got code showing up. Hooray! Okay. We now have code showing up in our little debugger. It's a little small. Let's go into our CSS for a second, and let's make sure our font size is just a little bit bigger. You can make it at whatever size you want, and then let's make a couple more designs here. Let's go ahead and say that let's find a bug prop, and let's say that it has a display of inline block. Does that change? Oh, look at that. Our bug prop is now inline block instead of block. We're going to make our bug K, which is our key, have a color of dark green and a font weight of bold. I said fart green. That's supposed to be dark green. Bug V is dark blue. And bug O is going to actually be gray. Let's try that. Hey, look at that. Our numbers are now blue. You know what? Even there, it's really small. I mean, you guys don't need to see it on the video, but even I'm having a hard time seeing that. There we go. 10 pixels. That's pretty small. It allows us to see it. Cool. If I now look at it, there we go. No matter what now, we are debugging our value. Now, you might ask yourself, shouldn't we have just found a way to use the console to show our debugs? Maybe. There's a couple of reasons that we shouldn't have used the console, even if the console could do it. One, there are certain ways of like watching a value, but I find that they are not as controllable as what we have just made. What we have just made means that we can have a name, we can design it all ourselves, we can really like make something that looks kind of however good we want it to be, and it can be quite good if we wanted to make it that way. So basically, I feel like this bug string should have a colon right there. Oh, that looks better. There we go. Sorry. We could basically make this with whatever we want, and that's why we made this. Why else did we make it? Because it's a fun way to see some things that you might not have done before. We just did some destructuring before. I don't know that I did that in any of the previous code, but destructuring is fantastic. Destructuring basically takes something like an object or an array and allows you to quick name all the parts of it. And it's great. Another fun exercise. Shit, is this the whole video? Should I just stop right here? We made a debugger. Is that the video? Is that where I'm going to stop? That's 45 minutes. Probably cut it down to 40. Last video was only like 30 minutes. That's a long video for debugging, man. I think there was a long point in there. I'll probably cut this down. It's still more than a half hour. You guys, this is our debugger. This is an improvement to our engine. I think I need to make another one of these. And the reason I need to make another one is because I have like 10 more videos of content ready to do. I just never sat down and recorded them before. I'm also saying you guys as if I'm talking to anyone. But you know what? A bunch of people watched the previous video and they commented. And that was awesome. And I love all of you. If you show up for this one, awesome. If you think I'm wrong, please hit that like and subscribe button. Tell me in the comments what I did wrong. No, but seriously, if there's a better way, which I know that sometimes there is a better way in JavaScript and CSS of doing things, I am constantly learning new ways of doing things, as I'm sure we all are in this space. If there's a newer, better way of doing any of the things that I'm doing, I would love to know about it and disagree with you or agree with you. We can have a fun discussion. Absolutely, I'd love to hear from any of you. I loved seeing all of the comments on the last one. I have to do more of these. This was fun. Yeah. That's all. I'll put this up in a second. Thank you.